The starting question of this paper tells us to solve the equation 4 sine theta plus tan theta is equal to 0, for theta being between 0 and 180. However, the problem here is that this equation just isn't able to be factorized yet, because we have sine theta and tan theta, which is not a factorizable format. So how do we get over this hurdle? Pause the video and give it a try. The key here is to remember that tan theta is equal to sine theta over cosine theta. And then knowing this, we then slot that into our equation. Okay, cool. So now we have 4 sine theta plus sine theta over cos theta is equal to 0. So what? How has using this helped us? This identity has helped us because if we multiply by cos theta, we get 4 sine theta cos theta plus sine theta over cos theta equals 0, which means that 4 sine theta cos theta plus sine theta is equal to 0 as a result. So what can we do from here? Well, remember the problem before. Here we couldn't factorize, but now with 4 sine theta cos theta plus sine theta equals 0, we can. And when we do, we get sine theta times 4 cos theta plus 1 is equal to 0. But now we have two equations. Sine theta equals 0 and 4 cos theta plus 1 equals 0. Let's attack each one by one. For sine theta equals 0, this is basically just asking us, where does sine theta equal 0? And by using your calculator or knowing the graphs, we can say that sine theta equals 0 when theta is equal to 0 degrees or 180 degrees, which is out of bounds according to the question. So we could write this equation off altogether. Let's turn now to our other equation. 4 cos theta plus 1 is equal to 0. Solving this problem, we get to cos theta is equal to negative a quarter. Now pay attention, because this part is really, really important. I used to fail trig questions all the time at this particular point. But after learning the following trick, I stopped this almost entirely. If cos theta is equal to negative a quarter, then obviously we have theta equaling a negative. And so if we go to our cast diagram, we have a few options to demonstrate this. We know that if cos theta is positive, it must lie in these two quadrants. But that isn't the case here. And so therefore cos theta must lie in these two instead. Now, what I'm about to show you is almost a bulletproof way of solving trig equations. If you want more info on this, click the link below. But let's solve this one for now. What we want to do here is to set up reference triangles in each of the quadrants where cos theta is negative. And then what we do is we solve for theta individually in each of those quadrants. If we do that, we get the following. And so our reference angle will be 75.5 degrees, as arc cos of a quarter is equal to 75.5. From here, we can conclude that our first angle must be 180 minus theta, which gives us 104.5 degrees. And our second angle must be 180 plus theta, which gives us 255.5 degrees. Now, 255.5 degrees is obviously outside of our boundary. And so we're left with 104.5 degrees, which fits our boundary and is therefore the final answer to this question. Okay, so here we're given two graphs and made to show what has happened to f of x in order for us to get to g of x. Now this question is really quite simple. All we have to do is take a look at a point on f of x and see what happens to that point to get us to an equivalent point on g of x. For instance, the point 5,3 on f of x corresponds to the point -1,6 on g of x. So what's happened here to make this transformation possible? Well, the first thing to notice is that we've gone from 3 to 6, which tells us that the y value has scaled by a factor of 2. Adding to this, we have shifted 6 units left on the x-axis with no corresponding shift in the y-axis, even though we have scaled. Two different things there. And what that tells us is that we've got a horizontal translation here by the vector -6, 0. Alright guys, so here we're given a line with the equation y is equal to kx minus k, which is a tangent to the line y is equal to -1/2 x. And the examiner wants us to find k and the coordinates of the point where the tangent meets the curve. Let's start off here by simply finding k, as that's going to make things much simpler for the next bit, as you'll soon see. So kx minus k is a tangent to -1/2 x. This means that at some point, kx minus k is equal to -1/2 x. So let's start here. Let kx minus k equal -1/2 x. Therefore, we can say that 2x times kx minus k is equal to -1. Which means then that 2kx squared minus 2kx plus 1 is equal to 0. Now, the next step here is to recognize something about what the line hitting the curve at the tangent means. Can you guess what it is? The line hitting the curve at a tangent indicates that first things first, the discriminant b squared minus 4ac must equal 0. And so, therefore b in this context is -2k. A, meanwhile, is simply 2k. And c is 1. And so we can say that we've got -2k squared minus 4 times 2k times 1 is equal to 0. Expanding this out, we get 4k squared minus 8k equals 0. Which means that 4k times k minus 2 is equal to 0. Which means that k equals 2 or k equals 0. Well, we know that k can't equal 0 because the question tells us explicitly that k must be a positive constant. So this means that k equals 2 by extension of this fact. Brilliant. So that's the first bit of the question sorted. And now on to the second. Finding the coordinates of the point where the tangent meets the curve. Now, as you can see, because we have k, this question becomes much more simple. Because all we have to do is plug k equals 2 into the equation we deciphered, which when we do, gives us the following. This can then simplify down to 2x minus 1 squared equals 0. And so solving for x just becomes an easy case of saying 2x minus 1 equals 0, which means x is equal to a half. And so if x equals a half and y is equal to negative 1 over 2x, that must mean that y is equal to negative 1. And so therefore our point is going to be a half negative 1. At face value, this question looks confusing, mainly because we don't have any tangible numbers. It's just p squared over 6 for the first element, 2p minus 6 for the second, and p for the third. Most people would freak out here, but not you, because you understand that in an arithmetic progression, the differences between the different terms are equal, which is important because it means that 2p minus 6 minus p squared over 6 is equal to p minus 2p minus 6, which we can simplify down to be 3p minus p squared over 6 minus 12 is equal to 0. From here, simply multiply by 6, rearrange, and we now have p minus 12 times p minus 6 is equal to 0, which means that p equals 12 or p is equal to 6. Question finished. Or is it? You see, remember what the question originally said. The common difference of the progression is not 0, which tells me that our only solution here is p is equal to 12. Okay, so here we have to utilize p equals 12 for purposes relating to a geometric progression now. After plugging in p equals 12, our first two terms of the geometric progression can now become a1 is equal to 24 and a2 is equal to 18. Simple. Now what's the sum to infinity? Well, the sum to infinity is a over 1 minus r, where r is the common difference. Now, how do we find r? Well, that's just two consecutive terms divided by each other. So with that in mind, let's do a2 over a1, which gives us 3 over 4. Putting this all together, we can say that the sum to infinity is equal to 96. So here we have a classic composite functions type of question, where we're given a value for f of x and then g of x, which includes f of x. The best way to think about these types of questions is almost like a reverse Russian doll, where instead of expanding out, we start inwards and build up. Applying that analogy here, if we get f of 7, that is 1 plus 2a over 7 minus a. And since we're told that f of 7 is equal to 5 over 2, that means that 5 over 2 is equal to 1 plus 2a over 7 minus a in this example. Solving for this, we then get a is equal to 3. Perfect. But now we have g of f of 5 is equal to 4. So what? Well, again, let's apply our Russian doll example. F of 5 is equal to 1 plus 2 times 3 over 5 minus 3, which equals 4. Therefore, we have g of 4 equaling 4, which means that 4b minus 2 is equal to 4, which means 4b equals 6, which means b equals 6 over 4, which equals 1.5. As a result, it's clear then that a equals 3 and b is equal to 1.5. What you need to remember here is that f of x is equal to 1 plus 6 over x minus 3. Now, f to the negative 1 is simply the inverse of f. And so if, therefore, the range of f, the sets representing all possible y values, will therefore be the domain of f to the negative 1, the set representing all possible x values. So then, what is the range of f? Well, 1 is the minimum value for f of x, and there's no upper bound, and so therefore f of x is greater than 1. And so therefore the domain for f to the negative 1 of x is x is greater than 1. To find the inverse here, there's actually a very neat trick. We know that f of x is equal to 1 plus 6 over x minus 3, which we can then convert into f of x is equal to x plus 3 over x minus 3 by simply utilizing the common denominator x minus 3. This just means that y is equal to x plus 3 over x minus 3. So what's the neat trick to find the inverse? It's actually quite simple. All we have to do is make x the subject first, and then reverse the roles, i.e. put y as x and x as y. To start off, let's multiply x minus 3 onto the other side. So we have y times x minus 3 is equal to x plus 3, from which we then get yx minus 3y is equal to x plus 3. So therefore yx minus x is equal to 3y plus 3 here. From here, x times y minus 1 is equal to 3 plus 3y, which means that x is equal to 3 plus 3y over y minus 1. Swapping roles now, y is equal to 3 plus 3x over x minus 1. And so therefore the inverse of f of x is equal to 3 plus 3x over x minus 1. Now this question represents a standard worded differential equation type of problem. The trick with these is to figure out what it wants us to find, for example dy by dx, and then from there use the other factors given to answer the question. Let's start with a question. What does it want us to find? Now it won't tell us mathematically, but it does tell us in words, which we then have to decipher. So it wants us to find the rate at which h is increasing which means dH by dt. Specifically, it wants a dH by dt when h is equal to 10 centimeters. Now, what about the other factors needed to answer the question? Well, we're told that dV by dt is equal to 500 because all dV by dt actually means is a change in volume over time. And we're told that at height equals h centimeters, the volume is equal to V, which is equal to 4 over 3, 25 plus h to the power of 3, minus 62,500 over 3. So altogether, we have these 3 clues to work with. And to find dH by dt, we need to first understand what dH by dt actually represents. dH by dt is equal to dH by dV times dV by dt. Okay, so now we have 2 components that make up dH by dt. We know that dV by dt is equal to 500, so we can simply leave that one there. Which means by extension, we only need dH by dV. But there's a problem. Can you see it? We only have an equation where V is the subject, which means we can only find dV by dH. Hang on though. This actually isn't a problem. Because if we flip dV by dH, we get dH by dV, which tells us that to get dH by dV, we differentiate our equation for V and then flip it. Perfect. So what's dV by dH? Well, dV by dH is equal to 4 over 3 times 3, 25 plus h to the power of 2, minus 0 now, which gives us 4 times 25 plus h squared. If we flip this now then, we get 4 times 25 plus h squared, which once we plug into h equals 10, remember this is what the question wanted, we get 1 over 4,900. As a result, going back to our equation, dH by dt is equal to dH by dV times dV by dt, which equals 1 over 4,900 times 500, which gives 5 over 49. Okay, so now for 9b, we're told that the rate at which h is increasing is 0.075 centimeters per second. Key points to focus on here. 1. Rate. And 2. H is increasing. What does this tell us? Well, what it tells us is that dH by dt is equal to 0.075 centimeters per second. Okay, so we're given dH by dt, and now we're told to find V at this instant. For starters, remember that dH by dt is equal to dH by dV times dV by dt, which means that dV by dt is equal to dV by dH times dH by dt. So, 500 is equal to 4 times 25 plus h to the power of 2 times 0.075. Now wait. Before we go any further, I want us to understand why we're doing this. The reason here is that if we find h, which is our unknown here, we can find v, because v is a function of h. So, recognizing that, let's continue. With this equation, we can break things down to get 25 plus h is equal to 40.8248, which gives us h is equal to 15.8248. Finally, knowing that v is equal to 4 over 3, 25 plus h to the power 3 minus 62,500 over 3, we can simply plug in h is equal to 15.8248 into our v equation. And lo and behold, we get v is equal to 4 over 3, 25 plus 15.8248 to the power of 3 minus 62,500 over 3, which gives us 69,888 centimeter cubed. Guys, now question 10 is really important because not only does it take up such a large amount of marks, but it also gets more difficult as things progress. To start off, let's ask ourselves what exactly they want here. We're basically just given a curve and then told to find the volume generated when this is rotated through 360 degrees about the x-axis. First thing to remember here is, well, what's the equation for the volume of a curve about the x-axis? Well, that's simply just going to be v is equal to pi times the integral between a and b, y squared dx. So, simply plugging in our values here, we get v is equal to pi times the integral between 3 over 2 and 1 times y squared dx, which gives us pi times the integral between 3 over 2 and 1, 4 over 2x minus 1 squared dx, which gives us the volume, right? Wrong. The thing to understand is that the above calculation incorporates the entire volume of the rotation, which is technically not what we want. We only want the shaded region. And since, when in 2D form, our shaded bit doesn't touch the x-axis, it therefore just doesn't make sense that in 3D it would either. So then, what's the solution to this? Well, the solution to this is to then take away the cylindrical bit from the equation. And what's that? Well, that would be the bit encompassed by the area 3 over 2 minus 1, which equals a half. Which when made a 3D cylinder has a volume of pi times 1 squared times a half, which equals pi over 2, according to the cylinder volume equation, pi r squared h. As a result, with this cylinder volume in mind, we can say that our volume is actually pi times the integral between 3 over 2 and 1 times 4 over 2x minus 1 squared dx minus pi over 2. This is great because it means we've just got past the hardest part of number A, which is really just an intuitive understanding of how the volume of a cylinder would look in this specific context. All we have to do now is integrate. And when we do that, we get 16 pi times the integral between 3 over 2 and 1 times 2x minus 1 to the power of negative 4 dx minus pi over 2. Now pay close attention here, because this is where it's really easy to slip up. Can you guess why? The reason is we have to do reverse chain rule, which gives us 16 pi times 2x minus 1 to the power of negative 3 over negative 3 times 2 And this is all bounded between 3 over 2 and 1. Then we minus pi over 2 at the end. Simplifying this down, we get negative 8 pi over 3 times 1 over 3 minus 1 cubed minus 1 over 1 minus pi over 2. Which when we continue to simplify down, gives us a final answer of 11 pi over 6. Alright guys, now for number 10b, it tells us that a triangle was formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. Given this triangle, it now wants us to find the area of it. So how does that work? How does one find the area of a triangle anyway? Well, its area is equal to half base times height. Our unknowns here are base and height. But height is pretty obvious. That's just 1. That tells us then that all we need to find is base. Now it seems pretty obvious from the get-go that the base revolves around 2 points. And so how do we find these 2 points? The first is from the tangent line. So when does this tangent line hit the x-axis? Well, to do that, we need to first find out what the equation of this line even is. Which can be done using our generalized line equation, y1 minus y2 is equal to m times x1 minus x2. So how is m found exactly? Simple. By finding dy by dx of the curve at 3 over 2. Doing this gives dy by dx is equal to negative 16 times 2x minus 1 to the power of negative 3. And then plugging in 3 over 2 after this gives negative 2, which tells us the slope of the tangent. All that's left now is to plug it into this, which gives us x equals 2. So therefore 2, 0 is our first point. Now what about our second point? Well, remember the slope of our tangent line, negative 2. Well, now we have a line going in the opposite direction called the normal, which we can say is a half because the normal is always equivalent to the gradient of the tangent flipped and multiplied by negative 1. As a result, plugging this in now gives x is equal to negative a half. So therefore negative a half 0 is our second point. So great. Now we've got height and we have base. Simply plugging this into the equation, we get a half times 5 over 2 times 1, which equals 5 over 4. Finally, the remaining question to go through here is question 11, with the first bit being okay, but then according to the examiner, the last bit was much harder to complete. So make sure to listen closely. The first bit isn't too difficult. Our unknown here is a stationary point, and we're given dy by dx also. So, all we have to do is do something to dy by dx, which can help us find a. And that is simply to plug a in and then set the equation equal to 0. Because dy by dx equals 0 at all stationary points. Doing this gives 6a squared minus 30a plus 6a equals 0, which gives 6a times a minus 4 equals 0. This means a equals 4 or a equals 0, but of course it can't be both. Why? Because it tells us at the beginning that a must be a positive constant, and so therefore a is going to equal 4. Finding the nature of the stationary point revolves around three things. 1. Find the second derivative. 2. Plug in the minimum point, which we have already found, which in this case is 4. 3. See if the answer we get is bigger or less than 0. If it's bigger, then we have a minimum. If it's smaller, then we have a maximum. Applying that method here, we can see that our second derivative becomes 12x minus 30. And plugging in x equals 4 gives 18, which is bigger than 0, meaning that 4 negative 15 must be a minimum. Question 11c. Finding the original equation of the curve boils down to two things. 1. Integrating dy by dx, because this gives you y. 2. Plugging in a point we know to solve for c. Doing this gives us the following. With c equals 1 when we plug in 4 negative 15. And so y is going to equal 2x to the power 3 minus 15x squared plus 24x plus 1. Following a similar pattern from before, finding the stationary points of a curve boils down to two things. 1. Setting dy by dx equal to 0, because the gradient is 0 at either a maximum, minimum, or inflection point. 2. Plugging in the values of x into y, which then gives us a value of y, so now we have a proper point with both x and y coordinates. In this case, setting dy by dx equal to 0 gives x equals 1 or x equals 4. We've already covered x equals 4 before, and that gives us 4 negative 15. Now with this in mind, we have to plug in x equals 1, which gives us 12, which tells us that our other stationary point here is 1, 12.